So the question is that true that the limit of the difference quotient is of form 0 over 0? We typically refer to this limit expression or this limit expression as limit of difference quotient. In a calculus course, your instructor will often point out that these limit expressions are of form 0 over 0 when the limit exists or when f prime of a exists. But in a calculus course, we typically find the limit of difference of quotient for functions such as polynomials, rational functions, radical functions, and a combinations of both. We even sometimes find this limit quotient for this type of functions that are not differentiable at x equal to a. So basically, elementary functions and some non-elementary functions have this property. This is the property. You may ask, how can we break this cycle? So notice in this limit of difference quotient, the limit of the denominator is always 0. If the expression is of form 0 over 0, then the limit of the numerator has to be also 0. So if you decide to make the limit of the numerator non-zero, then this expression is not going to be of the form 0 over 0. And if the limit of the numerator is not 0, then the limit of f of x as x approaches a is not going to be equal to f of a. What does that mean? That means that function is not continuous at point x equal to a. So what kind of discontinuities can we have? Removable, jump, and infinite. Let's try to give you an example of removable discontinuity. Here's an example. Here's another example. And in all of those, the limit of difference quotient is not 0 over 0. So if you're looking at this expression that mentions function is continuous, this expression is true. But if you're looking at this expression without mentioning that a function is continuous, this expression is wrong because we were able to give you a counterexample of that. I hope you enjoyed this video. I'm wishing you a very good analytical mind.